Hello everyone, I am Kalai SELVI, Assistant Professor, RMD Engineering College. Now we are going to see about artificial intelligence and intelligence agents. So before seeing in depth about the task environment, we are first going to see what is meant by AI agent or artificial intelligence agent. So we can say the replacement agent as a replacement of a human being. So for example, if you are considering a vacuum cleaner, that will be considered as a vacuum cleaner. Automatic vacuum cleaner will be considered as a AI agent. That machine will be considered as an agent. So it will observe the environment, the surrounding in which it is working. Based upon the observation and data which you're getting from the surrounding, it will take the decision to work or progress in that particular environment. So task environment is considered as a environment in artificial intelligence in which the agent is going to work. So the agent, it takes the input from that environment. So through sensors, and for example, you can take any PIR sensors, camera sensors, scanner sensors. So using that, the agent will take the input from the surroundings, and based upon that input, the agent will be pre-programmed with some particular task. So based upon the task, it will do the task, or if the agent have to take a decision, it will take the decision based upon the input and delivers the output to that environment through the actuators. So this is an example diagram of how the flow will be. So the agents, you can see the human nature, it will be replaced by the machine. So machine will be considered as an AI agent. So percepts means it will observe the environment and takes the input from the environment. So the sequence of instructions which you get from the environment, we can say the sequence of inputs will be considered as percepts in artificial intelligence. Based upon the percepts history, it will do a set of actions. So the sensors and effectors are available to get the inputs, and based upon the action, what are the effect, the after action work, what are the effects will be get back to the agent will be absorbed by the effectors. Next, we are going to see about types of task environment. Fully observable versus partially observable. Deterministic versus stochastic. Competitive versus collaborative. Single agent versus multi-agent. Static versus dynamic. Discrete versus continuous. Episodic versus sequential. Known versus unknown. So these are the types of task environment, and we will see one after the another. First is fully observable. So if the environment, that is the agent, can able to see the entire environment in which it is going to work, will be considered as a fully observable. For example, if you take a chess game, the agent can able to visualize the entire chessboard. It can able to see, the agent can able to see its own coin, and also at the same time can able to see the opposite person's coin also. So this will be considered as a perfect example for a fully observable environment. If we take for an partial observable, only certain portion of the environment can be observed by the agent. For example, you take a rummy card game. Online rummy card game, you can have the option of can play with the computer system, right? So the agent can able to see only the card which are which are there only in the display. If the agent cannot able to see what are the card the opposite person is holding. That is a perfect example of your partial observable. Next is deterministic and stochastic. If the next state of that environment is completely known to the agent based by the current state and the action executed by the agent, then we say the environment is a deterministic one. So example for this tic-tac-toe game. So based upon the current state, we can determine what will be the next state. So determination, we can say it as a correct flow of the game. That's an example for a deterministic environment. In stochastic, we can't able to judge what will be the action by what will be the next action. For example, you can take an example of a Ludo. So if a agent and a person are playing, if agent move a coin, the person may react in more than one way. So that cannot be decided by the agent. So based upon the movement of the person, after that only the agent will decide and take a decision and move his coin. Episodic environment. Each of the agent's activity in episodic task environment is broken into atomic events or episodes. So there won't be a link between present and past events. For example, you can take as a part-picking robot. So each occurrence, the agent will collect the environment input and based upon that, it takes the appropriate actions. So the entire task environment will be splitted into different events. We can say it as a subtask. Sequential environment. Previous decision in sequential environment can influence all future decisions. For example, give a checker game. So based upon the previous decision only, the agent will take his next action. So the next action is determined by what action he has to taken before and what action he expected to take in the future. Next is single versus multi-agent environment. If only one agent is involved in that environment is considered as a single agent. Example, maze game. If multiple agents can able to interact with the environment, then it is called multi-agent. So in multi-agent, you have two more types, competitive multi-agent, cooperative multi-agent. You can take a Ludo game as an example of competitive multi-agent because a simple Ludo game can be played up to 4 players. And 4 players will be have a competition. If you take an example of a cooperative multi-agent, cricket, football, only two teams and each team will have a 5 or 6 players you can play in each team. So you cooperatively have to play to win the task. Next is static and dynamic environment. If the environment can change while an agent is deliberating, then we say the environment is dynamic for that agent. Otherwise, the environment is static. So based upon the change which he observed from the environment, the agent will take his own decision. Example for static environment, crossword puzzle. For the entire game gets over, the crossword puzzle environment won't change. But you take an example for dynamic environment, taxi driving, based upon the driver's instruction. For example, starting the road may be clear, the driver agent, so driver is an agent can able to ride the car and after 100-meter distance, they may interrupt, the agent may get interrupted by traffic or person, we can say it as a zebra crossing or somebody will come in between. You have to see the traffic signals. So based upon the environment inputs, percepts, the driver has to take this own decision. That is the environment of for the taxi driver AI agent is a dynamic one, that is changing one. So based upon the changes, the driver has to take his own decision. Next is district versus continuous environment. In district environment, there will be a finite set of percepts, and for that particular percepts, we have finite set of actions. Example, chess game. If for a continuous environment, we cannot able to number the percepts. For example, self-driving car. Known with unknown environment. The result of all the action will be known in this type of environment. Example, playing cards. So if you are if the agent is choosing a car or dropping a car, for each that actions, the what will be the possible output can be predicted by the AI agent. But if the prediction of the output cannot be decided, then it will be say it as a unknown environment. Example, video games. So in video game, a simple game like driving a car, or you can take Free Fire. You can't able to predict what will be the next action, as the environment will be changing dynamically. So unknown environment will be suited for dynamic changing environment. So these environments are the good examples for exploitation and exploration, which will be seen in reinforcement learning. Thank you.